we actually have been wanting to do a Git talk for a long time now. In my experience, Git's one of those things where it's actually like most developers always underestimate like how hard it is to actually get into it and kind of understand it and make sense of it initially. So I think between Shaylin and Justin and me, we've been talking about doing one for a very long time now. And kind of when this CodeBridge project came up, we thought this is actually like a really good opportunity to do a talk on Git, and then also like allow some space for people to actually like practice and implement those, like what they kind of learned. Yeah, and then Robert actually mentioned that he was keen to do a talk on that. Yeah, I put up a little bio on the meetup. I'll let Robert do a better introduction of himself, but yeah, like Robert's someone who I've been following for a while now. He's kind of one of the I want to say like kind of one of the people I really kind of look up to in terms of like just general development, like advice, and kind of just like he has a lot of experience within development, and I certainly have learned a lot from him. The first talk I attended of his was on Kotlin, on Java. But like he's also super involved with like DevConf and so forth. So I couldn't think of anyone who's actually more suited to present this. So then I'm happy to hand over to Robert to kind of do his own intro. That is if I haven't frozen. Okay, I haven't frozen. Great stuff.
Hey, well, thanks to you for that amazing introduction. I feel like really honored by it. Yeah, I don't know how much I have to pay for that sort of introduction in my normal day. It'll be great if we can get that. Let me just share my screen and we can get started. I have no idea how to ever see chat while I present. There we go. So hopefully that'll be up there. Right, so this talk is on Git. So my name's Robert. I do a couple of things. I occasionally write blog posts. I'll put up slides and everything on my website, SADev. I also run a conference called DevConf, and also help run the developer user group, which is a sort of monthly get together for topics just like this. We try to be a really nice sort of friendly place for new speakers as well. So if you are interested in talking and presenting somewhere, learning how to get into presentations, let me know. I'll be glad to have you come to the user group. So what is Git? It's a tool if you've never heard of it. There's some fun history stuff we can talk about later if you're really interested. But it really is, it's a way of managing your source control, so your documents. Traditionally, like programmers would use it, but you can actually use it pretty much anyone who has to work with text files. If you are working with like 3D printing, you can actually save your machine profiles into Git and version them and see like the history of them. And that makes it a great way for sharing source code, for sharing projects. It makes it a great way for learning because you can read other people's things. You can see your evolution. It makes it very easy to do a lot of experiments because you can then actually go through and try things, make mistakes, roll back, fix them up very quickly. And yeah, really it is basically just a magic time machine that will let you do all kinds of things. It comes in a command line mode, which is what I kind of use most of the time in my day job. It can feel a little bit overwhelming, the command line, but there are like nice, pretty interfaces for it as well. I'll switch between the two I use most of the time. But really with the command line, you kind of learn about a few commands and you'll be okay. It's really not horrendous. This was on Twitter last night. I thought this was great because trying to figure out how do you talk about Git, and we can, there's two really good approaches. We can go down the whole graph theory approach where we can sort of deep dive into how things should work, or we can learn like 5 commands and what to do when it's broken. So naturally, I assume for this audience, the graph theory approach is the best one. So no, I'm kidding. We're not going to do graph theory. I don't even know how to do graph theory. Yeah, so these are the 14 things we're going to cover today in hour-ish time. I'll go kind of quick, but if you do have questions, I will glance over to the other screen and see what they are. But don't worry if none of this makes sense or if these words sound weird. Hopefully some of them seem familiar. Fork potentially would be a good one if you've heard of that. At least not maybe in the Git context. But let's start with how to get Git. Like, you know, get good, get Git. First thing, you can just download it. You can download the command line version from the website. If you do have a Mac or a Linux machine or a Windows machine, you can get it through their standard sort of package manager stuff. You can run a command. It's pretty much everywhere. Or it's available in pretty much any of your, if you're using a development tool, they all ship with it nowadays. It's pretty common to get it. I'm not going to show you how to install Git because we want to watch a progress bar. What happens once you've got Git? And that's going to sound so weird. What happens when you've got Git on your machine? How do you configure it? What's the next step? Well, the first thing is just to actually, there's a command config option. So if I switch here, so this is my little command prompt. And once you're installed, you can just type git and you get all the commands that are available. Obviously, there is like git help if you ever need to bring this back up, and you can get help on command. So if I wanted to check the help for config, which is what we're looking at now, I can hit that and I get pages and pages and pages of useful information. But really, if you want to set some value, you just actually say like git config, and you can say if it's a global setting or a local setting. So is it all over your machine or just for the project you're working on? And then you can set like your username, for instance. So you can see like I've just done like set my username there. You can actually list them all out as well. Hey, let's go back here. List, I think. No. So I only have 2 settings set up on this machine. And really you only need to worry about this. This is just really to associate whatever work you do with who you are. So it's just like, this is my name and my email address. There are lots of other config things you can set, and you can really deep dive into lots of cool functionality with it. But really, you know, that's all that matters there. And what happens with these config files, with the config stuff, it actually is just text files. Actually, I think it's under config git. No. Actually, I know where it is. There should be a git file in here somewhere. There, git config. So if I just print out that file, .git config, you can see it's just a normal text file. If what I'm typing here seems weird, cat is just like a way of printing a text file. You could run Notepad if you wished as well. And so you can also just edit these text files if you want. You can back them up and save them. It's totally doable to do things like that. So that's really the first and most important thing in just getting it set up. So download, install. Hopefully if your internet's fast enough, you've probably already done that. And then you can run like the setup and be ready, run the config. If you're using a GUI tool, it will prompt you quite easily to get ready with it. Now, let's do that. I'll never learn how to do Windows weird screen changing stuff properly. First thing, the very, very first thing everybody needs to do is like, how do you make a new empty place to work? So normally you'll create a folder. So we'll call this demo day. And we'll go into demo day. And you can just type git in it. And there you go. I've made a git thing. It's now git. It's that easy. Once again, if you are working with a development tool or something like that, you will have it built into there. Now, for what we're going to do today, we're not going to need to do this. I'll show you how we actually grab existing repositories. A repository, for those of you who don't know, it's just a name for like a collection, a Git folder, basically. So we will be able to grab that folder from a shared location and get it onto our machine. But if you wanted to set up your own for your own experimentation or things like that, that's how you do it. And I thought it'd be kind of nice because I'm going to show you some commands we'll use like while working on it without actually touching the proper official thing, because I don't want to break anybody's actual proper work right now. So the next command that you really have to know about is status. You can do git status. And if I just type that, you can see I'm on branch master. I'm not going to touch on branching today, but you can think of branching as being able to split out your folder into like virtual subfolders and be able to switch between them. So if you want to do a bit of work on something and then switch back easily, you can do that all in sort of one place. Quite really useful. I have no commits yet, so I haven't actually put anything into my Git repository. I'm not tracking anything. But if I wanted to add files, it even gives me the hint of what we're going to need to know next, which is git add. So let's get there. I mean, I like to use a program called Visual Studio Code for like the work I do. So if I fire it up here, it will actually pop up and connect to that folder. And on the left-hand side is the source control. I'm just waiting for it to open. And give it a second to register everything. You'll see here, it knows it's a Git folder. And if I had any changes, it would be listed in here. There's a like refresh thing there. We'll come back to that in a moment. But you know, you can have these sort of nice, easy to read experiences in whatever you're using. But for today, probably you actually can get away with avoiding it and just use the command prompt. It's not going to be that complicated. So how do we add a file to this, right? So the command is add, nice and simple. And it doesn't actually like commit that file. So if you think something like Dropbox, you would take a file and drop in a folder and it's there, it's now syncing. Git's a little bit more complicated than that. So you have your folder with the files, but Git doesn't actually just follow every file you put in there. The reason for that is because you might not want to put every file or track every file the whole time. So you can actually add it to say, Git, please start tracking this file. And then it will start to work, like you can start to work with it and you can start to do what we call staging. So staging is like, I'm going to take a bunch of work and get that ready to like commit and say, this is a thing and it's complete, or this is a logical point to wrap this work up in. So let's have a look at that. So let's do this in here to start. We'll actually create a file in Visual Studio Code because it's nice and sort of visual here. So I'm going to hit new file in here. We'll call this file1 because we'll file.1. Let's make this really like weird out. Cool. So I have a file in here. If I go to my git status, you can see it spotted a change in here. If we go to the command prompt, we can do git status in here. You can see here is this untracked file, which means that Git's not going to do anything with it. It's just going to ignore it for me. It'll just be listed under untracked files. So I can do git add, and I can say file1. And if I run that status again, hey, here's this file we're now tracking. And when you're ready, we will commit that. So we're going to create a point in time and say, this is what the file looked like at that point in time. And that comes back to that sort of time machine thinking. It's like, here's the point of time, here's another point in time, and we can change backwards and forwards. If I switch back to Visual Studio Code, you'll see it's now moved that file from changes into staged changes. It's getting ready to do it. We don't have anything in this file. We should probably put something in here. First time interview. Otherwise, it'll be really weird. All right, so we put some changes in there. We'll click stage that again. And we'll come back to what we can do with that. Git does try to be very useful in terms of like the help messages, even on the command prompt. So if I wanted to remove that, if I wanted to do the opposite of add, it tells you here exactly. It's like, hey, git rm cached file to unstage. If I was to have a second file, so let's make another file. We'll do this one in the command prompt. So touch just creates a new file. So here I've got a second file. So we can do git status. There's my second file. It can get tiring, or if you have lots of files, to just keep typing each one. You can just use dot as the wildcard. I've never understood why it's just dot, but it is just dot. So now I've got two files in there. And I should have two files listed here, both ready to go, ready to create that sort of point in time. So let's go back here. My slides are all just so I can remember all the things I'm supposed to talk about. So now we get to the really fun part, commit, right? So you're going, most of the time in my day-to-day, I'm doing git add, then git commit, and then I send the changes from my local machine to a shared location. And then I get the latest changes from there. And that's kind of all I do. It's like 3 or 4 commands, and I never look at the rest. And git commit is one of those big 3 or 4 commands. So it tells Git, like, this is the point in time, save all my work at this point, so that if I need to roll back or come back to it, I can. If I want to compare it, I can do that. So let's go and do that. So there are a couple of ways to do this. Once again, depends if you're going to use a nice graphical interface. But in here, we could type a message and click the tick box that will do a commit. Or if we do it the command prompt, we can do git commit here. And it pops up a little text editor. And the reason is you should always have a helpful message to remember what you're doing, right? So this is the initial. That's kind of a common one. It's also kind of a good practice to come in here when you are putting like commit messages and things like that. If you have some sort of work item or something you're tracking against, or some more, some description, you can add it into here. So if this was like, from our task board for today, this was like work item 10, I could do something like work item 10, just so that if somebody's looking through the code and looking through the history, which you can do, they can easily spot these sort of things. So in this text editor, I press Control X to exit and say yes to save, and it saves. And now that is committed. If I do a git status immediately, that will say, hey, there's nothing to commit. Everything is clean. Everything's ready. Like there's no changes that have happened. If we come back to Visual Studio, you'll see there are no changes here. It doesn't mean there are no files. The files still exist. They're still here, but there's just no changes to those files. So if we come into here and we'll change a file now, first edit, and we can check our status in here. You can see we just have that change there, and we can now go and do that. Let's go and commit this one in here. Nice and easily. Boom, done. And so we've got 2 commits now. And it's just, generally what will happen is you kind of keep your commit messages nice and short and readable and easy to follow is a good advice on that. And, try to make them a bit more useful than mine. Saying this is the initial commit is not useful, but saying this is the commit that deals with this file, or this is the commit that deals with this parsing. That's kind of the useful things in the messages to add. But it really isn't that big a problem. And the nice thing with Git is if you get anything wrong, you can always roll back. You can always undo, which makes it very easy to work with. So how do you see the history? So we've done that git commit, but we can't see any changes. We can't see stuff. So how do you see that history? And how do you work with it? So if I go back into my command prompt here, I can do git log, and it shows me the history. It'll show me who did it. So this piece here is pulled from the config that we saw on the second slide. Obviously, date and time that is putting in there, and there's my messages that have been putting in. So you can see it's kind of very useful sort of stuff. And it's in reverse order with the newest at the top and the oldest at the bottom. And you can see it's got this number here. This is a commit hash or commit ID. This is like the special number you can use to like identify this commit. So, if I want to say, hey, I need to change to this one, I can give it this number. You can actually give it a sub portion of the number. You don't have to give it the whole number, and say, okay, roll back, go backwards in time to that number. And they are already long. That's to avoid sort of problems with them, like having 2 people having the same number, because if we're both working on something, which is one of the joys of Git, we both work, it's a collaborative way. We don't have, if you commit something and I commit something, we don't want them both to have like the number 5. So there's some clever maths behind this. It's absolutely useless to know for day-to-day work on it, but that's the number that we'll use on that sort of stuff. And we'll have a look at that a bit later. Naturally, when talking about Git, you have to include XKCD comics. And this is one of 2 for this talk. So, and that is pretty much how everyone's comments will go. So don't worry about it if you feel like your comments are bad. You're probably like your messages are bad. You're just like everyone else. So how do we undo a change? If we have, there's 2 ways to do it. So if we haven't committed the file, we can use a command called restore. And if we have committed the file and want to go backwards completely in time, we can use a command called reset. Prior to fairly recent changes, they used to actually use reset for both of those, and it makes it a bit confusing. You can actually still use reset for both as the command, but all the guidance is to use restore now because it's a lot easier to read and understand. So if we go in here, so let's go and play with restore for a second. So let's go and say, like make an obvious mistake and say, this is for, file 3 in here. We'll jump back in here and we can do git status. There's the file, right? It's all like incorrect and we know that. So I can just do git restore file 2. And if we do git status again, everything's clean. And if we come back to here, you'll see that this file has now gone back, first edit to file 2. So it's undone that change. We can just put some nonsense into file 2 and do it in the UI. So actually what's great with the UI is when I click on it, you can see the difference. It shows you a nice, pretty experience here of the sort of what has changed between the two. But in here, it's just, discard the changes and it rolls it back. So you always have that safety net. Now, if we wanted to go back, there we go, back in time, that's the reset option. So we can go get log. And so let's say I want to get rid of all of this work here. So I can say git reset, and I can put in this. Now, there is an option here. Just in case you're wondering how I did that, in my command line, if you just, I'm on Windows 10. If you click and hold, you can select text with your mouse, and then to paste is just right click. So if I just do that and do right click again, it'll paste it in. I'm sure keyboard shortcuts also work if you're into keyboards. There are two options with git reset. If I jump back to my slide somehow, where is my slide? There we go. You can add what's called --hard onto it. So I can add this extra piece, and that will undo all the files for me. So it's kind of, I battle to explain this one really clearly, but we are going to get rid of this file, or the contents of this file, because that's what we did in the second commit, right? But maybe I want to, maybe the problem is not this file, but maybe it's the commit. Maybe I want to do some more work on this. This was an okay starting point, and I want to keep this and build on it and redo that commit. Then you wouldn't add hard because you want to keep that content. But if you add hard, you're actually saying get rid of the content as well, roll back time and roll back all the files. So let's have a look at both quickly for this. So I'm going to do normal git reset back to that first one. And you'll see here, if we do a git status, that file is now modified, right? So we've rolled it back, and git log, we only have one commit here. And if we go back in here, you'll see this file is unchanged because the content of the file is unchanged because we didn't give it that hard, right? We just told it to roll back the timeline, but keep the contents. So let's do this again. We'll just commit this in here. And let's go back in here and we can say, so we've got git log in here again. There's our log. You'll see we've got a new number here compared to previous ones. So let's do git reset again. Let's grab a shorter version of this just because that's such a long number. And we'll say --hard. Now what this will do is it's going to roll back time as well as it will remove the contents of that file because that was what was in that commit. So if we do that, git hard, and we do a git log, and we're down to just the one commit, and you can see that contents of the file is gone. So if you're unsure or worried about doing a rollback with reset, don't add hard because at least you're not going to lose anything that way. The only thing you lose is your nice handcrafted messages in your commit. If you are worried about, if you are confident about what you want to do, hard's a really good option to kind of speed things up. And restore is nice for changes you haven't committed, haven't done anything with. Cool. Just looking at chat, lots of people are posting in the chat about various GUI tools they use. There are so many. there are lots and lots of really good ones available out there. GitHub, which I'll talk about just now, actually has some nice ones as well. And once again, this is a nice thing about this, because it's open source, because it's available for everyone. Everyone can build on top of it. Everyone can add to it. So it makes it very easy to work with and find something that works for you. And just a reminder, if you are interested in diving into the work that we're doing today, and not too interested in like learning about Git, there is a second channel, second room setup. Skulk will paste the link to the room in a moment if you want to like skip this and jump straight into doing the work. So let's have a look at the next command, which is diff. This is definitely a case where I don't like the command line tools. I think they're kind of awkward to work with, and the graphical tools are a lot better. So let's go set something up in here. Really lazy. So we'll have that in there. Nope, that's not what I want to do. And so if we go git status here, you'll see there's the file. And hopefully you can see it's like I'm doing git status a lot. It's like git status, git add, git commit, git status. It's kind of all the commands you're going to use as well. So if it does feel a little like, oh my gosh, there's all these commands, see, notice the fact it's just the same like 3 or 4 things over and over again. So that's the changes there. We haven't committed them yet, but I will run git diff. And that prints out this, and this is why I'm not a big fan of this. It takes a lot to sort of understand what it's trying to tell you. It's a really weird sort of shorthand format. But it's basically trying to say, it's like, hey, we're going to compare these 2 versions of the file at these 2 points of time. And this one, this is a new line. It's got a little plus symbol at the start. So this is a brand new line that was added. I'm sure it's some people who probably spend more time with the command line find that a lot easier. The GUI tools I use have nice things like this where you can see it very easily. Let's commit this one. And because we can also git diff more than just type git diff like that, we can actually tell it, hey, give us a git diff between things. So I can say, right, git diff against, and we'll the old commit. And so now it's showing between where I am now and where I was in the future, where I am now and where I was in the past. So we only have 2 of these, but if I have more commits, I can sort of pick any 2. I can actually add, say like git diff between this one and this one. And then it starts to print those, like give me the differences between them. So you can just like throw in these things and see them in here. Once again, this is really an area where command line, graphical tools I feel are better. My favorite little tool here, Visual Studio Code. You can see if I click down here, there is bring that up a bit, a timeline option, and I can actually click on that and see exactly what is happening. So in the initial commit, what's nice is it's based on the file I'm looking at. So if I go to file 1, you can see it's only ever had something done on the initial commit. If I go to file 2, it's had 2 commits. So the first one, it was empty. And then the second one, we had some text. So I find it really nice and simple to work that way with git diff. Right. So that's kind of, if we've almost touched on all the core components, but obviously we're just working locally. We're not working with something distributed, working with other teams. So for that, we have to use some sort of service. GitHub is one of the biggest in the world, if not the biggest ways of sharing code. And everyone will tell you that it's really important for open source and everyone puts their stuff there. But honestly, the real importance of GitHub is trying to get an Octocat, which is their mascot and one of the best parts about GitHub. I have an Octocat. I don't know if my video is showing, but I've got an Octocat somewhere back there sitting on my shelf because I quite like them. They're very cute. So what is GitHub? I decided when I was making this slide, I got bored of bright sunny colors for one slide. So I made this kind of a nice, more muted color. It is a central location for anything you want, right? Normally source code, but people, like I say, put any sort of text type document. You have data, like the data we're working with today, it can go into there. You can have it public or private. So if you want a place to put your private code or your private projects, you can put it there. And it makes it really great for sharing. There are some tricks if you're going to use like binary formats, so not like things you could open in Notepad, that you can use with it as well. But generally, it's more sort of the text stuff that kind of fits into there. And it's a great place for like sharing content. So obviously today, we're working with this. So if you haven't been to GitHub yet, or you haven't started yet, obviously in addition to the software, the Git software, you'll need to come to github.com, create an account, it's free, and then click on the link to get this. And this is, you know, all the sort of Git repository for the project. What's nice in here, we can go into this. I always get confused with their sort of experience, but you can see here is the last commit from, we can see who it was. Skulk did it, what his message was. We can click on this. I think this is actually linking to a number. Oh, no, yes, that links, that is the commit itself. So that was like all the details in it, or the pull request. We'll get to that in a moment, what those are. And so that you can go through this, see all the files, navigate through it. And really it's just sort of a central place to do it. And there's lots and lots of things on GitHub, not just the stuff we're doing today, but like massive projects, massive like open source things. Visual Studio Code that I've been using, as well as Git, are both also hosted on there. You can go get their source code. And what's nice with anything public is you don't need permission. You can just get it. So the way we do that, let me jump back here, is by cloning. So you basically get to make a copy of whatever source code is somewhere, and you pull it down onto your machine, and you can set it and work with it later. Now, this is something you kind of do very rarely. In a work environment, you're going to do this sort of once at the start when you start a project. If you're like joining with like new projects, you're joining with like new open source things, working something like that, you would just do this sort of as you start. So today, you're probably only going to do this once, unless you completely break something on your machine, and then you might do it a second time. So how do we do that? If we go back here to Visual Studio, to GitHub, there is this giant green button here, code. If you click on that, it gives you some options here. So if you have the GitHub desktop software, you can click that link. If you're using Visual Studio, you can click this link. But I'm going to do it the old-fashioned manual way, which is you just take this line here, the HTTPS one, click copy, and we'll go back to our command prompt. Let's go down to here. And when you clone, it's going to create a folder for you. So it's not going to put the files directly into that where you are. It's going to create like a subfolder and put the contents in there. So I'm going sort of one out of my little demo folder that we were working in because I want this to be sort of next to that. And we just type git clone, and I can paste in the link I got, right? And I hit enter. And now hopefully the internet is nice and quick for us. It is. And there we go. I've cloned it. So I can now, if I go in here, let's see, what did it call it? Data cleaning. Cool. So now I have all the files. And you can see these are the same files that are up here. So there's a forestry and fisheries, presidentiary. I can't speak this morning, it's too early, and I have not had coffee. Tabular, cooperative governance, all these files are here. And I have them on my machine, and I can work with each one of them. These are all CSV files, so they're normal text files. I can, once again, go in here, hit Ask Visual Studio Code to have a look at them. If you are a fan of Visual Studio Code, or you do have you want to play with, want to try it out, it has some really cool plugins that you can add. If we bring this one up here, it should in a moment actually load up a plugin I have for like CSV data to make it a lot more readable. Where is plugins again? There we go. I can't remember. Oh, actually it might not be installed yet. I'm trying to remember what the plugin's called. It's like a better CSV, or like a really pretty CSV sort of thing, like formats your data really nicely. So we have that in there. You can see I've got all my subfolders in here. I can work with that. And I can do all the things we've done before. So I can do git status, nothing's in there. I can do git log. I can see all the commits in here, going back to however long ago it was. And I can go in here and say, hey, I want to like git diff. Let's have a look at sort of what happened at this point. I'm just picking one at random. And you can see here is all these things that were added at that point. As, comparing, sorry, not added at that point, comparing what was in that point to what we have now. So all the green has been added since then. So lots and lots of things have been added in there. And so it makes it really, really easy to do. And so today, you're probably going to do that just once. If you are using a graphical editor like Visual Studio, there will be some way to go in and actually set it up. I can't remember how we do it in Git. It's been so long. Oh, there's clone. So you just go in here, you hit clone, and it will bring it down for you. It really is sort of that sort of once-off thing that you need to worry about. Thankfully, not too hard. So yeah, it's really nice and easy to work with. Right, so let's talk about forking. So forking is not a traditional Git thing. It's also a really awkward word to say. It's more of a GitHub thing. And so if you think about what's happening here is I have all this code here on my machine. I can edit it and play with it and manipulate it. So I could delete this, or I could change all the values in the CSVs. But I don't have permission to go and actually upload it back into here, right? And that's for security. We don't want random people from the world just coming around and like throwing stuff at us. But I do want to be able to work with it. And how can I do that? So GitHub has this concept called forking. And what that does is it makes a copy of whatever this is for you on GitHub. So that you have, so if you think about this, this is sort of I got rid of that too quickly. This is controlled by everyone on this project, all the admins on this project. But if we want to have a place that you control, you can make a copy of this in GitHub, and it's called a fork. And to do that is really easy. You just come up to the top right, you hit fork, you choose, I have multiple things set up on my GitHub, but in your case, you just have one. So I'm gonna probably click on your name, and it's now going to make a copy of that. And you'll see here, I'll have a project called data cleaning, and it's forked from that. And this gives me a nice, easy place to sort of work with it. And then I can go and clone my copy. So let's do that. Yes, please. Let's get rid of the existing copy, just so I don't run into weird problems, and get clone. And you'll see here, now it's got my name in there instead of the official one. So I'll have this nice, easy place to work with all of this. So I can do whatever I like in this now, and manipulate the data, add new files, edit files, things like that in this folder, completely without sort of any sort of problems or anything like that. Visual Studio should be all okay here. So I've got my files in here, and I can now, let's go create a file in here. So we'll create a text file in here. I really haven't written hello world in a text file for years. That's a thing people used to do, I'm sure. So I can put that in there. I can go into here. We'll do our git commit. Let's do a git commit on command prompt. So git status. So we'll do git add dot commit that and git commit, adding a demo file. Yes. Okay. Cool. So I've added that file into there. That's a good example of something about Git. You can see here I can't spell, but it did try to help me actually. So that's what I wanted, git status, git log, and you can see here we go. I now have one with my name on it, which is quite cool. So I can go and work on this. Now you can obviously do that locally, even with the version if you clone the original. But the reason you want to have your own fork or your own copy is so you can upload it and work with it really easily there. So we get onto push and pull, which is really the essence of how do we share stuff around, right? And once again, you can see once you've made a whole bunch of slides, you get kind of bored of the same thing. So I decided that I had enough with circles. I needed some squares for this. So push, we send data to our server. Pull, we get data from the server. In this case, the server is GitHub. So if I want to update my copy, say I'm working with some other people, I can just type git pull. and it will pull my stuff. It's got some warning things here because I haven't set up something in my config yet for it. But that's fine. It does it anyway. It's just a warning, and it says I'm already up to date. Or if I'm in my command in Visual Studio here, I can go in here and say pull, and it will pull down, and it won't give me any warnings either, which is a nice feature. And if I want to upload my copy, if I want my changes, because this is connected to my fork, my personal one, I can just say git push. And it will ask me for my username, and then it's going to ask me for my password, and I have a long, complicated password. So I need to go get that in a window over here, and hopefully not show everyone what it looks like. GitHub, copy password, paste that in there. Oh, that did not work. This was my only worry with this thing. This is copy password. Hopefully you can't see what's on the second screen. All right, git push, put in my username, paste my password. Nope. I don't know why I can't push now. Git push. Try it one more time. I gotta try and remember what Windows command line stuff is. Or keyboard stuff. No, interesting. No, Nicholas, my password isn't that easy. I wish it was, but it's not. I'm pretty sure that is my password. My password is definitely looks similar to that. Try it one more time. Because I'm pretty sure I'm not copy pasting something correctly. We can try this. Let's try it actually. I had it practice this one, but let's push in here and see what it does. So if I say push, and mostly because I used the Visual Studio, oh, it had my password stored in Visual Studio already. So that's cool. It did a push. It did a things. Git status. Everything's clean and I'm up to date. Command lines, they can be tricky. And I shouldn't have a long, complicated password for uploading. But if we come back to my version here, so this is not on the official one, this is my one, and I hit refresh. We will see in here, hey, I've added a demo file, and there is my demo file that I've added. And I can actually even click on it and see what's in it and see the history on that. Go into here, actually, and see the history on it, click there. You can see the commits for that file. And it's nice really with like Git, you can go through and see all of this sort of stuff and it's all available. And so generally what will happen is you sort of work on something, you do a git pull, get all the latest things, commit your code, do a git push, upload your things. And that's kind of, you know, most of what you do day in and day out. Right. I will answer your question just now. I see it, Skulk. I will talk about that at the end. Right, let's go to this. So now that I've got my one, how do I get it? It's not really useful because it's just my one. Maybe it is useful. Maybe I just want to take somebody's existing piece of work and like riff on it and make it my own and add some feature they don't have. And I'm not too concerned about going back. But in the work we're doing today, we really do want it to go back, right? We want it to get back into that main repository. And so what I can do is called a pull request. And a pull request is a way you can say, I have a fork of code and you have the original. Here is my request. Can you pull the changes from my fork into your one? And so to do that, we'll go back. We can go into here, if I remember right. And we're going to go new pull request. Okay. And that's the base repository where we started originally. And my repository is the head. And you'll see here, this is, hey, this is what's going to be in here. It will show you exactly what is listed. So it's my demo, my one commit, my demo file and my content. And I can go click create pull request. And it's going to take whatever my notes were in my commit message that we spoke about earlier, put it in here. But in theory, you also want to go and add some more content in here. You want to add some more information because this is not just your commit message. This is also so that the person knowing what's going on. So I can go, you know, doing a demo and I can go in here, paste in my message, and hit create pull request. And yep, I was going to do that anyways, and like make an actual pull request. And so now it's in here, and there's a proper pull request, and you can see who can review it, and who's got permission. And if it's a valid, useful thing, they can say yes and bring that content over. And if they think it's nonsense, like it is, they can say no and deny it and give you feedback, which you can then use to improve it. So let's see, like Skulk has now added a comment on it, so I can get feedback on that. It's really useful. I like the fact that Skulk and I didn't practice or prepare anything like this. This is just completely how great demos go. And yeah, cool. It's been merged in. So it's been accepted. My code is now properly inside this actual project, which is quite crazy. We should probably clean that up for them in a moment. And it's been closed, and so there will be a history of it. And now in the main one, if I go back up to here, you can see there is my demo file, which is crazy. So from Yegs, a pull request is basically asking to push the original one. It's called a pull request because you're asking the original to pull from your modified. So your modified, your fork location, pull from there into your one. But it's just a nice way of doing it. It's a bunch of structure around it. So it's not just like, oh, get this data and bring it in. It's here is some information about it. Here are the people. Here is the process where I can add content to something else that I don't have permission to by somebody else like approving that work. So pull requests, and for today, pull requests are kind of going to be one of the things. So yeah, Skull's comment is exactly right. You know, we have push, which we use to upload content to the server, pull, which we use to download content from there, which are get things, and pull requests feel like we're kind of throwing content at the server. It feels like it should be a push request, but it's actually a pull request because it's the other way around. It's one of these weird, you know, you can see an engineer came up with a name because it's exactly right for the engineering explanation of it, but it's kind of not how people would think about it. So that is the main things. So if you can do get add, get commit, you can do a get pull, you've got a GitHub account, you can do a pull request, then you're done. And that's everything that you need to know. And so that's, you know, going back to the final XKCD, which I think is by law now required in every Git slide deck. If you do get anything wrong, the worst case is you just kind of go in here and you go, oh no, it's all broken. I'll just delete it all and then git clone it again, and it's fine. It's totally okay. Everything is going to be totally okay. So with that, I'll answer some questions. Let's see. I'll stop sharing there, make it a bit easier for me to see what's going on. Right. There was a Skull's question. Skulk says he prefers using HTTPS over SSH. So on Git, actually, I shouldn't have stopped sharing. Let's share that again. I'll show you what that's about. It's a very interesting thing in GitHub. If I go to clone, there is a number of options here. I have HTTPS and I have SSH. And you can choose sort of different ways. And these allow you to control how you communicate with the server. They're both secure. They both keep your stuff, you know, you're not leaking out passwords and things like that. What is nice with SSH is you can create sort of a key, and you give the server one key and you keep one key, and you don't have to type a password in all the time when you work with SSH. Whereas if you work with HTTPS, you can see you either have to have something that will keep your password for you the whole time. So like in my case, Visual Studio Code does that. On Mac, Keychain does that for you. But if you're on just like command line on a Linux machine or on Windows, you might have to just keep typing it in. I think for the stuff I do normally, I use SSH at work. I don't use it at home for some reason. So it's a preference thing. I think it is, you can put some checks in. Git push with SSH means you don't get prompted. Exactly as Douglas was saying, you don't get prompted every time for your password, which is also a good thing because it's nice and easy to work with. It's a really bad thing if you just mistakenly push stuff. But worst case, you just do a git reset and roll back. So it's not too risky there. But yeah, they both are good. If you are, for today, if you're new to this, HTTPS is going to be fine. Just don't pick a really long, complicated password like I had. And if you are going to get more into Git and things like that, SSH is really pretty good with that. So here's a question from Ryan is, once I've made a fork, so I have a fork somewhere. Where did my fork go? Let's go back here. How do I keep my fork up to date? So my fork is no longer in, well, my fork is still up to date at the moment, but how do I like update my fork? You can go and actually force an update there's a command. So it's actually with git pull. And I cannot remember all the details on this. So git pull, oh wait, now we're gonna get into the real crazy stuff. Git remote will let me know. Git remote origin? There should be a way to see all of these. Pull. Yeah. I don't remember the exact thing. I can find the command just now for you. But you can actually say, like, in your local one, you can basically do like git pull from the original source to your one, and it will bring it down. If you are doing, oh, look, I'm already behind this one here. This branch is behind that one. I can actually do a pull request to myself, is a second way of doing this. So I can come in here. No, why are you saying that? Can you please update? So you can actually pull the other way. So let's swap this around. Does that work? No, I would have thought that would have worked. Wrong cleaning, data cleaning, and nope, I'm getting it the wrong way around. You can pull across backwards to yourself if you want as well, if need be. If you're only doing sort of one file, it's also okay to kind of go in here and just make another fork and delete it and keep working on that. But I will get that one there. Updating origins is not something I do very often. That's why it's not on top of my mind. But let me go, I'll get that for you just now and post in the chat. Right. From Nicholas, when you are the maintainer of a repository and a contributor does a large pull request of their code to your master branch, it can be like pulling teeth amount of effort. Yes, it can. Hopefully you trust, you have things that can help with that. The stuff we're doing today is going to be a bit awkward because they're sort of just big CSV files and we have to use a bit of trust, but you can actually put some tooling and things like that in place to help in other scenarios. So you can do things like every time somebody does a commit or does a pull request, it runs this command or runs this tool, and that checks if it's a healthy piece of code. It will run some tests for you and check if it's valid. You can have it run things like, does this conform to our coding standards and things like that, which helps with sort of automating away a lot of the pain and suffering there, so that you can focus on the actual code. It's also totally okay as a maintainer to just say this pull request is too big and I'm not going to deal with it. You need to break this into smaller chunks and resubmit them into sort of smaller chunks. And that's, we do that at work as well with our one. When we do pull requests, if they're too big, we go back to the person and say, it's like, it's going to take me 3 days to review all this code. Like, why have you sat on this for so long? There's probably something else wrong in our team, which is why we do lots of small commits with lots of small pull requests, because it makes it easy to understand. Also from Nicholas' question is like, when is it good to use tags? So what you can do with Git is you can do tags. So I don't have any tags on this, but I could add a tag. I haven't done this for a very long time. You check what the command on that is. It is add a tag. We just do git tag. So git tag demo1. And then I can check my tags. There you go. I have a tag. Tags are useful for sort of having easy to reference points in time. So if I do git log, it should actually have the tag up here. There we go. You can see the tag. So instead of having this random weird number, I could tag it. Generally, things that you release, you know, some way of marking a piece of work is done is a good thing to have. So in this case, you know, I have this tag here. This might make sense for this project, might not. The only time I use tags normally is actually every time we do a release to production at work, it has a tag, and that tag is the date. And so I know, oh, okay, this is the code that went out that day, and this is the code that went out that day. And I don't have to kind of sift through lots of messages and lots of things. What's nice with tags is you can see it's independent of your commit. So while I have a commit here, I can tag it afterwards. And once again, that makes it nice and easy for working with it. So from Douglas, is it better to use a CLI for GitHub, or is it better to use a GUI as the command line is more efficient? Either or. Anybody who tells you one is like significantly better than the other is only talking for themselves, in all honesty. I use the command line a lot because I'm used to it. I would not say it is better or worse. If you use the Git, like I know GitHub has their own nice GUI nowadays, and a lot of people like that. And there was a bunch of really good GUIs shared earlier. Source tree apps are quite a popular one that I've heard of. I don't know Git Cola that Nicola shared. But yeah, it's, you know, if you are starting out, the GUI might be easier because, you know, you don't have to try and remember all these weird commands. But yeah, if you learn the command line, you can use it also anywhere. Pick what works for you. You won't be wrong. That's the joy of this. Yeah, so that, any other questions from anyone else?
I have some of my own, but like I obviously wanted to open the floor first. Let's maybe see if there are any other ones. Does anyone else have any more questions? So there's another question. It was actually a response to Douglas. Cool. So like maybe I can just ask my question. Merge. So Nicholas posted a question, literally just the two words, merge conflicts.
Yeah. So, yeah, so I didn't touch on merge conflicts. That's a pretty good thing to mention. So merge conflicts are the fun problem of what happens if I am working locally on my version and somebody is working on their version locally, and then one of us uploads, and then my version is no longer in sync with it. Now Git is pretty good at trying to deal with that. So when you do a Git pull, it will actually try to figure out, oh, this is what changed, and this is how we will fix that for you. But sometimes it's going to have problems. Sometimes it's going to run into these scenarios where it's like, you changed, you know, if we go back to our original demo here, you can imagine if we're both working on file 1 and I change like this to first, and then Skull changes, even if he doesn't change that word, he could potentially change like, you know, times, I don't know. Git doesn't know what the content of this is. It doesn't know it's a programming language or a text file or CSV. It can't determine that. So it's going to come down here and it's going to say, hey, this file has these changes. In your file, you have this line. You have one line that looks like, let's actually copy this. You'll have a line like this. You have first, and in the other file, we have this line. Which one do you want? This is definitely, once again, command line makes this really awkward. It doesn't have any good tooling. You actually have to open up the file, and they have this sort of structure here that looks like, I think it's something like this, which is like hair or like origin. I never actually look at these. And there's like a line and then yours, remote or something like that. And I think it's common is the middle one, which is the like original line. And you'll be able to see sort of that sort of thing. And what you should do if you're working on the command line is you kind of delete all the stuff that doesn't apply. So if you think, oh, okay, well, I think my one is right. I'm going to delete everything everybody else wrote. And these little weird comments that Git puts in, then you save that and you commit that. What's nice with it is you can also go and edit here. So I could look at this and go, oh, well, Skulk, actually, that makes sense. We should have an S in there. I'm going to kind of do both and do it that way. I wish I could force a Git one of these sort of things. They're a bit awkward to try and demo. This is definitely a scenario though when GUIs are better, because if you do have something like that, what will happen is you'll get something like this in Visual Studio, and you'll actually have a button that says like which one of them, and you'll be able to see each of the different options and be able to say, okay, that's the one I want, that's the one I want. And you just basically have to go through each one. They are time consuming and annoying if Git can't do it, but Git does try to do a very good job at like fixing it up. You really have to end up like working on the same line in a text file for it to happen. So yeah, but yeah, hopefully for the stuff we're doing today, I don't suspect we'll have many because we're kind of all working on separate files today as we upload files. So it shouldn't be too difficult to avoid too many merge conflicts. From Ryan, is it better to push changes then pull or pull then push? It's always pull then push. Git by default will, if you try to push changes and you're out of sync with the server, it won't let you push those changes because it's trying to protect you from just like thumping somebody else's work away. So it's always pull then push. You pull the changes from the server, you deal with any conflicts, any issues, and if there are, you fix those, you do a commit, and then you do a push. And if there was none, you just do a push straight away. So yeah, that can help. From Nicholas, question is Git versus Subversion. Would the key question be, what would the key question be when selecting one at the beginning of a project? That's an interesting one. They're different technology. They both do the same job. They both give you a way of managing source control. They do it in slightly different ways. Subversion, SVN, has to have like a central server, and you always have to work with that one server. Git has what they call a distributed model. We're kind of getting back to, where is my slides? Look at all the stuff we learned today. We're kind of getting back to that problem. It's like when it's like Git has all these interesting, complicated things buried under it, makes it different from Subversion. And maybe I will take a hard stand though on this and say it's always going to be Git nowadays, because everybody does it. Like I think you can Subversion if you're on a legacy project or something like that where you're using it, it's probably okay. But you know, if you are building something open source, it's going to be Git because you want to be able to put it somewhere, and everyone in open source does Git. If you are in a corporate environment, you might have Subversion some places, but I think if you are looking to get people to come work with you to give your developers a really good experience, a lot of them are thinking in Git. A lot of people just learning Git. I have people I work with who've never worked with Subversion. So yeah. Yeah, so I mean, I would like if you really dive deep into it and you have some really complicated reasons for Subversion, you could go that route, but I think Git would be a safe choice 99.9% of the time. Also from Nicholas, I heard rumors in the past that Git is not reliable with binding files. Why would someone say that? It's because Git doesn't know what the file is. So it's just the contents of the file. It can't do merges and things like that on binary files. It's too tricky. And you can't, in theory, maybe you can, maybe you're a lot smarter than I am and you can merge binary files manually and not break things, but most people can't. So it's not great with that. And so not only does it have that problem, like the merges become really awkward and you kind of just have to do these big overwrites every time. And you lose a lot of that graphical experience. It also gets really expensive because Git keeps a history of everything. So if I commit this file, let's just do that. You can see my Git commit message is looking really good now. So you can see in here we have a whole bunch of history in here. On my machine, I have all the history for all the work that Skulk and everybody else has done on this project now. I could unplug my internet and be able to like roll back and go back to it. And the way that works is there is actually a Git folder that is not CD Git. There's a hidden Git folder, and in here is all the history. Now, the big thing there is the way Git tries to make sure that this folder doesn't take up your whole hard drive is it stores the differences every time. So, you know, if I just do, let's do git log again, git diff, and we do that. It's just stored like this tiny bit. It doesn't have to store every file for every version. And if I make a change to the file, it's only going to store like the difference inside that change, and it does it quite efficiently. But if you have a binary file, if you have a 1 meg binary file or 1 gig binary file, it's going to have to store every single one of those. And so you can easily like run out of disk space or have like massive repos and be very slow. There are some things on the, if you are worried about it, there's a thing called Git large file system support, or large file support, LFS, which exists, and you can use that in conjunction with it, but it's not ideal. I'm a proponent of like saying, like, if you need to store like big binary files, like movies or audio, if you do a podcast, or things like that, you're probably better off putting them in another system that's a little bit better, something like Dropbox or OneDrive or things like that, where they kind of work a little bit differently, and they only keep kind of the latest version. Going back to your previous question about SVN, though, SVN only stores a point in time thing. It doesn't have all that history. And so SVN is actually a lot better for big data files. And that's maybe a good example of where you could use both. So if you wanted to have like a copy of all your database backups, because I know teams that have done that, you put those in SVN and you keep all your source code in GitHub or in Git and use both. So yeah, exactly. Exactly right. Yeah, if you had zip files in there, because zip files are binary files, and you try to merge them, it would corrupt them. So yeah. Yeah, and storage would become an issue with large files on your machine, but it builds up over time. I mean, I'm not even sure how big this folder is on my machine, how big the Git folder is on my machine at the moment. It's how big, because it's got all the history of all the files. So it is also something to think about. It's like, don't commit things you don't need to. And that's why Git has that concept we spoke about really early. I did mention it very briefly, but back right here is that you do staging. So you can choose what file. So if I had a file, maybe I need a really big file for something I'm working on here. Big file, zip. And I can then just avoid staging that. I don't add that in. So that would be a way to go around that, which is quite useful. Yeah. Anyone else? Skull?
So yeah, I have a couple. So I think, let me first just say, I think your response to the subversion question was very graceful. I would probably not have I would probably have expressed very much stronger views against subversion. But what I often see is, it's rarely that I've met anyone who thinks subversion is superior to Git. What I do get quite a lot is a lot of people advocating for Mercurial, saying that Mercurial is a lot better than Git. I think my response is just like, I just tend to go in terms of market share. It's just like, I'm not going to onboard every single developer that I get on my team into using Mercurial for the first time. Have you used Mercurial at all?
Yeah, I was, I mean, going into the history now of like this sort of stuff, both Git and Mercurial came from the same origin, ultimately, which is the Linux kernel. They were using a source code repository system, and the company that made it was letting them use it for free, but then wanted to charge other people, and two of the people who worked on Linux came up with different ways of doing source control. One created Git and one created Mercurial. And I was a big fan of Mercurial. I think it's an easier one. It does away with staging as a concept. It does internal structures a little bit differently and things like that. It was quite nice. But yeah, I haven't touched Mercurial in many years. Mostly because, yeah, it's there's no one who supports it.
Mm.
The big companies that used to support it, like Bitbucket, which is like a GitHub, and they were a big Mercurial fan, they don't support it anymore. It's just really hard to keep your source code in it unless you're like in your company in sort of thing like that. So yeah.
Yeah, and I know like GitHub does support it to a certain degree, but with several caveats. So, and I think to me that's also one of the things of Git is kind of the entire ecosystem around it as well. You know, like stuff like continuous integration, continuous deployment, those type of things, and so forth. So I'm surprised this question hasn't been asked before, but rebase or merge?
Oh, yeah, that's a good question. So for those of you who don't know, so merge and rebase are different ways of like of getting combining the code together, and it's how it manipulates history. So when you do a merge, you have like your two files, and then you create a new one, and you commit that, and it creates a new point in time thing at the end of the time. So your timeline would be like my change, Skulk's change, and the merge. Rebase lets you edit time. So you would be able to actually like merge the files together, but then not necessarily even create a new one. You can just have like, oh, this is, Skulk's change, my change, and then I would do a rebase, and then it actually just Skulk's change appears, the merge all gets handled into there, which is really nice. I'm a fan of rebase because it gives you cleaner logs. I think it's a better way to go. It's also more complicated. It's, if you're on a team and you just starting using it, just use merge. It's fine. You won't be wrong. When you get to really big projects and you have lots of people committing and things like that, or, work environments where you really have to dig through things for like reports and stuff, rebase can make your logs a lot nicer, a lot easier to understand.
I tend to advocate for merging just because like I agree with you in theory. Like when it's just me alone working on the project, I would probably rebase. But I've kind of just found that kind of when things go wrong with rebase, they go catastrophically wrong. When things go wrong with merge, it's usually a lot easier to fix. So I don't want any juniors kind of breaking my repository. So I just say, just merge everyone. So then another question from my side is, I don't know if you have experience with this at all or have any opinions on it, but there's kind of been kind of a rise of, sorry, someone was actually asking about maybe you explaining the rebase merge again.
Sure.
Yeah.
This might be easier if I do it this way. So I'll draw something. I'm doing mouse drawing, so I do apologize for the horror that is obviously trying to draw on a screen with a mouse.
I'm expecting nothing less than an animated GIF.
Oh my gosh, no. Right, so I mean, like you can imagine. So I have my commit that lives in a specific point in time, and like then Skulk does his piece, and I need to add that into mine, but there's conflicts. This is also very weird. I'm doing this the proper Git way, which is that the arrows flow the other way. So this would be 1 and this would be 2, but the arrow points the other way. And now what would happen is I've made a bunch of changes. So I edited a file, Skulk edited the same file, and I've pulled his changes down onto my machine, but they conflict. So now I've got this, I have to make I'm going to make the merge file, the file that merges those two together. It's a new change. And so then I pop that change onto the end of the queue, and it's number 3. And so that there is like, oh, okay, now, hey, I've got this thing. And so in my log, I would have 3 things listed. I'd have my original commit with my change, Skulk's original commit with his change, and then a third commit with what was merged, what the decision was. Rebase goes like this. I've got my original change, and I pull Skulk's change down onto my machine. But actually, Skulk's change got to the server first, right? So his change is actually newer. And so what rebase does is it says, okay, well, we'll move Skulk's change ahead of yours in the timeline. And then we have your change on your machine. And then any merge, any conflict, any changes like that, just go straight into here. they don't make another extra commit. And so when you do if I did a git log with a merge, I get, mine, skulk, merge. And if I do with a rebase, I see skulk, mine. That's it. And you don't see the merge. And it literally is like nice and clean and easier to read and things like that. That's kind of how, hopefully it makes a little bit more sense with that. It's fundamentally you end at the same point, right? The code here at this point and the code here at this point is identical, right? The merges happen, these things happen. This is just how you want to represent your history within Git. I did see another question here from Sam, which is how can pull requests be done on the command line without the GitHub interface? I have no idea. As far as I know, it's pull requests are not a Git thing, so it's not part of the Git command line. There might be a GitHub command line or a GitHub extension that you can add that will give you things like that. I know Visual Studio Code has a plugin that you can add that gives you pull request support inside there, but pull request is technically a GitHub thing, not a Git thing. And the fact that these things are terribly named, one's GitHub and one's Git, they sound like they're the same thing, but they're separate. One's made for like sharing code, and one's how do you have a central place for that sort of stuff. So yeah.
I think it's also important to note that when you say GitHub, you're kind of referring to GitLab, Bitbucket, like all of these. They tend to, but in this case, we're specifically talking about GitHub. But most of these kind of competitors to GitHub, like also have like pull requests, forks, those type of things. It's kind of very standardized, kind of a standardized way of kind of treating I almost want to say the meta level of Git.
And they're really good. I've done a lot of work with Microsoft Swan. I think it's called ALM, or like Azure DevOps now is the name for it. Yeah. It's really nice, and they obviously support pull requests and things like that. I work with GitLab quite often, which is fantastic. They also have all the same functionality. The only thing that's weird there is they call their pull requests merge requests. It's literally just a name difference, but yeah, they have all of that. And there's also Bitbucket, which is quite popular. I think those are probably the big 4 places that you can kind of put source code up for free and work with people. But GitHub is far and away the biggest in terms of market share and where everybody kind of is. And more projects are there every day. I just heard like OpenJDK is moving there as well now. So it really is kind of like everything kind of is falling into one sort of social network for source code, I guess.
Yeah. So I think my initial question that I wanted to ask before we return back to Rebase was, there's kind of this rising kind of concept of, treating your actual data in like kind of putting it in version control as well. It's mostly it mostly comes kind of out of kind of the Jamstack kind of approach. But I know like one of the big ones that did it initially was Smashing Magazine. So they like, for those of you that don't know Smashing Magazine, they kind of like one of the biggest like design front end webby kind of like publications. Probably between them and kind of CSS Tricks and a list apart, they're kind of the 3 big ones. So what Smashing Magazine did, they used to have a WordPress, they used to run on WordPress, and then they kind of moved over to kind of a more like Jamstack kind of approach. And they actually do their data in version control as well. So they're actual articles. So for example, if you were to edit something to an article, you would actually do that through Git. You would have like a pull request, hey, change the heading of this article. So they would like, and I think their argument is actually that Git is actually like a very good way to kind of manage content as well, in addition to code. So I'm interested in your thoughts on this. If I would wager a guess, I'd probably say you're probably not that big of a fan of it, just because of your background. But I'm interested in hearing your thoughts.
Yeah, so that's an interesting one. Let me show you something here. I gotta try and find it. Hey, screen share. I think I can't remember what the name of it. DevConf So I mentioned before I run a conference. It has a website because you have to have websites. So that's a website. If we go in, it's all obviously because the website we have source code. It's all in GitHub. It's all here if you want it. We have all our data for all the tracks and all the management stuff in text files in here, so you can kind of see all the sponsors and links. I think it works really well to put it in here and publish it. There's also something really cool that you can do with with GitHub specifically. I set this up last night because I needed to share something. You can easily just come into Git. Actually, let me do this differently into GitHub. If I go to repositories, I can go create a new repository. We can call this whatever. I will delete it later. Just does not make a difference. The name you should care about the name, but for this demo I'm not going to care. And you can go to settings once you've created it, not put anything in there. And if you scroll down the settings, there is actually a button right down here, GitHub Pages. And if you choose a theme, you can pick whatever theme you like. So Time Machine, since we're doing Git today, select theme, and it will pre-populate an initial setup for you with pages. And if I commit that change, you'll see it's just a normal, in this case, it's Markdown, which is just a text format. But what is nice, if I go back to settings, and we go back down to that GitHub Pages, that will actually have a link to it. And I can open that up, and it will have there you go, I've created a web page. And you can set themes and stuff. And it works fantastically. I think you can use other things. They use a tech called Jekyll. But yeah, it's that hard to build up a web page. And you can do things like set the headers and everything in files and exactly that way. As I mentioned, I use it for my stuff. It's really good. Would I use this if I was at a major bank running their corporate website? Probably not, but that's because there's other aspects, or maybe, it might be part of it, right? But there are other things you need to do. If you're running a big website, if you're running like for a multinational like Ferrari, and you need to do press releases, you actually are required to issue press releases in multiple languages. So you actually have to have a workflow. So somebody writes something and then it goes into approval, and then somebody else approves it, and then it has to go to a translator, and the translation has to be approved, and you have to have those like little steps. But you can have the output of that go straight into Git. Into GitHub and have that go there. So it could be a very good sort of place. But generally, once you get to that sort of level of complexity, there are kind of specific tools that help. But for a lot of people, I think it's, a lot of things you can build with GitHub is really good. And you can actually have custom domain names and things like that on there, which is quite nice. Cool.
So you can actually, I don't know if you've heard about like kind of Netlify CMS. There's also like I think Forestry is the other one. So those actually provide kind of a GUI that kind of uses for example, the GitHub API. And it actually, those kind of steps you described in terms of making an edit, saving a draft, pushing it to live, those actually correspond to pull requests and commits and merges and things, and it kind of abstracts it in a GUI, so you don't even need to understand Git. So yeah, that's very interesting. I use it quite a lot, but I'm also kind of aware of my own biases here. Like you tend to come from a more enterprise kind of world, where I tend to come more from, I almost want to say the punk rock school of coding. So it's something that gels with me a lot better. I see there's another question regarding checking in, checking out.
Yeah. So, this goes back, Subversion, tools like Team Foundation Server, things like that. They used to have a way of saying like, oh, I'm going to check out this file. Like, I'm the only one today who can work on this file until I check it back in. So Git doesn't have that because you're not connected to a server. When I'm running commands, I'm running them on my local machine. So I can't sort of check out a file and say, nobody else touched this, because there's no sort of central server to manage it. Subversion lets you manage it, because if you want to do something, you always have to be connected to that sort of central Subversion server. And so Git, you're kind of always working separately, and only when you do a push or a pull are you actually talking to the server. So it doesn't have anything along those lines. But yeah, I mean, merge requests, I don't know. I hear you on that they're scary. I guess it's just, hopefully you're doing nice small things. Hopefully you're, working with people who know to don't do big pieces of work all at the same time on the same file. Sometimes it happens and it's just painful. The joy of Git, though, is you have a full history. The other person has a full history. Even if you get it completely wrong on your side, you can always roll back. It's a really safe place. And that kind of goes back to my original slide of it's a really good place to do experimentation. With Subversion, you would get a merge conflict and then you have fix it and then you commit it and you're committed. It goes straight to the server. With Git, it doesn't go straight to the server. You did your merge and it's on your machine and you can test everything and work with it. And then you can edit it and fix it up if it's still broken. Or you can just delete that, roll back your local one, pretend it didn't happen, and try it again. So you have a lot of sort of safety nets in Git that you don't necessarily have with also Subversion and things like that. That kind of help with those sort of scenarios.
Cool. I think that about covers it, unless anyone wants to sneak in a last minute question. Okay, doesn't seem that way. Cool. I think that maybe speaks to just how comprehensive you were, Robert. Yeah. Nicholas.
Would Git be considered blockchain? No, but I mean, I'm sure if we took some Git and blockchain and threw some artificial intelligence in it somehow, we could get $30 million in venture funding.
Some machine learning in the mix as well.
Yeah, always.
Yeah. So cool. Thanks a lot, Robert. I really much enjoyed this. Even I think as someone who's been using Git for a very long time now, even I learned a couple of things. To me, Git's one of those things where most of the time you encounter it, you just need to start getting up and running. So very few of us actually have the time to kind of sit back, go through all the Git documentation and so forth. So to me, myself, this was really interesting seeing some kind of blind spots I actually have in terms of fundamentals. So well done on that. Yeah, thanks everyone for joining. So this is actually being recorded. I'll upload it on YouTube and just share a link on the meetup for anyone that's interested. And I think, so we can maybe now get into kind of the practical work. So the actual project that Robert showed. So I'm going to invite all the other overachievers back in that actually wanted to skip this talk and just get started right away. Obviously, Robert, you have no obligation to stick around. You're more than welcome if you want, but I also know you're a busy man. So
yeah, I'll definitely be around for the next while. So
okay, cool.
I'm more than happy to help out.
Cool. So let me just ping JD.